Now let's talk about two different probability distributions that we'll go over. The first being estimated probability, or sometimes called relative frequency, and the second being theoretical probability, or we might refer to it as modeled probability. To understand estimated probability, we'll employ the following scenario. Suppose at a grocery store you examine apples, checking to see if they were bruised. The frequency of bruised apples would be the number of bruised apples observed. The comparison of frequencies can be misleading. Suppose at store 1 the frequency of bruised apples was 20, and the frequency at store 2 was 4. Your conclusions on which store you should avoid to prevent getting bruised apples would change if you are also told the information that at store 1 you checked 100 apples, and at store 2 you only checked 5. This extra information is utilized in the definition of relative frequency. Relative frequency is the frequency of some event divided by the entire sample size. Using relative frequency as a probability distribution defines the probability of some event E as the frequency of that event divided by the number of trials. In that previous example, the relative frequency of bruised apples at store 1 is 20 over 100, which is 0.2, and at store 2 is 4 over 5, which is 0.8. As a probability distribution, relative frequency, or estimated probability, has limitations. The field of statistics studies ways to measure the trustworthiness of estimated probabilities. Our second probability distribution, modeled probability, defines the probability of an outcome as the predicted relative frequency of that outcome over a large experiment. The fact that relative frequencies even stabilize as the number of trials increases comes from the central limit theorem. For experiments where every outcome can be assumed to be equally likely, we can directly calculate the modeled probability.